Welcome to our Getting Started guide for the Amazon Lookout for Vision Accelerator PoC kit. My name is Mark Hebel and I'm Head of IoT and Application Development at Basler. Today I will show you step-by-step instructions on how to assemble the kit, a possible setup so you can get good quality images to train your ML model later on. After the setup, I will guide you through the booting process, show you how to configure the camera, and most importantly, show you how you can feed Amazon Lookout for Vision with the acquired sample images so that the neural network will be able to visually distinguish anomalies and defects on products and parts. The Amazon Lookout for Vision Accelerator PoC kit is a prototyping kit that is suitable for anomaly detection for use cases such as defect detection and quality control. The Amazon Lookout for Vision Accelerator PoC kit contains all hardware and software components that you need to start the prototyping process. Let's quickly go through them. The kit comes with a 2 megapixel ACE USB color camera with global shutter technology and a suitable lens. For our neural network to be trained reliably, we need constant sufficient light conditions. This is assured by this ring light. The ACE camera can easily be positioned in the center of the ring light with included camera mount and 4 screws. As edge device, we have an NVIDIA Jetson Nano developer board, which is protected against ruggedness with this housing. All necessary cables, accessories and power supplies are also included. A 5-meter USB-free cable with micro B screw locks, a 5-meter GigE Cat6 cable, a supply cable for the ring light, and 2 power supplies, one for the edge device and one for the ring light. We recommend a test setup similar to the one you can see here, as it makes it easy to obtain the required images so that later on you will be able to train the neural network properly. Please make sure that the object to be inspected is at least 10 centimeters away from the lens. Now I'll show you how to set up the kit. First we will start with the ring light. This is the ring light. You have to attach the camera mount firmly to the ring light, screwing it tightly with the supplied screws. The cable supplying power to the ring light is this one and has to be firmly screwed into the back of the ring light. Now attach the lens to the camera. Now take the camera and lens and attach it to the camera mount and the ring light, so screwing it firmly with screws from the back here. Now connect the camera to the box using the supplied USB-free cable. First connect the camera, making sure to screw in the cable properly, and the other end of the cable is plugged directly into the box. Then take the GigE cable, plug one end into the box and the other end into your network. The last stage is the power supply for the box. Before plugging it in, please make sure to connect a monitor and a keyboard and a mouse to the box for the next sequence. Plug one end of the power supply into the box here. And when you're ready to go to the booting sequence, plug in the other end to the power. Let's turn to the software side of our kit. The software is pre-installed on the edge device. The stack includes our Basler Pylon camera software suite and connectivity to AWS and hence to Amazon Lookout for Vision. I will guide you through the booting process, show you how to configure the camera, and how to train a neural network. After setting up the kit, please make sure that a monitor, a keyboard and a mouse is connected to the board before applying power. To start the boot up sequence, just apply power to the board. Please be patient. It may take some time before the board has booted up. After the system has finished booting, please read the NVIDIA end user license agreements and accept the terms of this license. Then you will be asked to choose which language you wish to configure the system in. Please choose the language you want. You will then be asked to choose your keyboard layout. Please choose the keyboard you would like to use and then click Continue. Please choose the time zone you wish to use. Now enter a username, a computer name for the computer, and then choose a password. You can require your password to log in, or you can log in automatically. Then click Continue. You then have to choose the APP partition size. Just choose the default which is suggested. Also choose the default for the NVP model mode. It will now install the system. You have successfully booted your computer when you see this login screen. Before doing anything else, please log in with the password you chose before. You will be presented with a desktop. Close the keyboard shortcuts, go down the screen and please double click on the icon marked Terminal. You will be presented with a terminal screen as shown. In the terminal, type in IPADDR show. This will list all network connections on the board. Please scroll up until you find ETH0, which is normally the third connection. Please note the INET address shown here highlighted. Yours will be different. You will need this later on to use the GUI from another machine. After this, you can log out and use the remote GUI from any desktop browser connected to the network. After successfully booting the kit and acquiring the IP address, go to a browser on a computer in the same network as the kit. Enter into the browser address bar the IP of the kit, which you got earlier. You should see the following UI being displayed. The UI has three main parts: a configuration part for configuring the camera, a training part for training your network, and an inference part for performing the inference and classification of the objects. I will now go through all of these one after the other. To start with, we have to connect the kit to the AWS cloud services. Do this by clicking on the green button marked Create AWS Resources. The following pop-up will turn up and you are now ready to create the link. Clicking on this button here, Create AWS Resources, will open up a new tab in your browser and take you to the AWS console. If you're already logged in on this browser to the AWS console, you will go straight to the page, otherwise you will have to log in first. You will be taken to this CloudFormation page, where the CloudFormation stack has to be created. can accept the default stack name and default device name, or you can change it. Please click the Acknowledge button. This allows the system to create the I am role in order for the kit to be able to speak to the AWS services. Then click Create Stack. If this was successful, you'll be taken to the stack overview, showing that your stack creation is in progress. Creating the stack takes a few minutes, and when it is finished, Create Complete will appear here under your stack name which you chose before. On this system, several stack names have been created. If this is your first use of the kit, you will only have one. Then go to Outputs and copy this device cert URL. Go back to the kit page with the pop-up and copy the device search URL into the text box as shown. Click OK to finish the integration.
Now the camera has to be configured. On the left hand side you see a live image showing the board that is currently being inspected. Use this live image to position the board inside the image window. Adjust the exposure time and gain to make sure the board is clearly lit. In this case the board is a bit too dark, so increase the exposure time until it can be clearly seen. Also, if the object to be detected is not taking up the whole picture, you can use a select region of interest in order to only concentrate the camera on the important part of the board. For instance, here the whole image has been taken. Adjusting this area of interest will allow lookout provision to focus on the important part of the image. Like so. Depending on how much the position of the board can vary in the image, you should make the ROI tighter or less tight. Always taking in mind if it's possible that the board may be in a different orientation between picture to picture. After choosing the region of interest, click Apply, and now the camera will only concentrate on the region of interest. So, after the camera has been correctly configured so that the object to be inspected is clearly visible in the image area, you can move on to training. Click on the Training tab. Also in this view, on the left hand side is the live image, showing you what the camera is currently looking at. On the right hand side, you have to select an image label depending which kind of image this is going to be for training. Available are Training Normal, Training Anomaly, Test Normal and Test Anomaly. Clearly, one set training is required to train the neural network to detect normal or anomaly images, and one set testing can be used to see how good the trained network is. In order to train a network, it is important to have a training set. The testing set is optional. So make sure that a normal, correct board without defect is under the camera and select Training Normal. Clicking the trigger button will send one image to the AWS cloud, correctly labeled as selected in the pull-down. So in this case, I've selected a Training Normal. There is a thumbnail of the image that was sent to the cloud, and the table showing the number of images per set has been updated to show one image. Doing another picture will update to 2 images. This has been done for normal for 20 different images, and then change to a board or several boards which have an anomaly or a defect on them, and take at least 10 images for training anomaly set. Please remember to vary the orientation if this is relevant, or any other factors in the lighting or anything in the room if this will affect the picture images being trained. Once you have taken a minimum of 10 training anomaly images, you're ready to train the model. Click on the Add to Lookup Provision button. Again, there is a pop-up showing you where the images have been stored in an S3 bucket. This information must be used in a minute, but we can get it then. So, clicking Create Dataset in Lookup Provision will again open another tab showing you the AWS Lookup Provision console. In the AWS Lookup Provision console, go through the options under Create Dataset, which are shown. If you have only used the testing set, then leave the default setting of Create a Single Dataset. If you also wish to use a testing set, then choose Create a Train Dataset and a Test Dataset. Tell Lookup Provision you want to import the image from an S3 bucket. And now you have to tell Lookup Provision where this S3 bucket is. Go back to the Kit tab. In this case, copy the training dataset out. Go back to Lookup Provision tab and copy that S3 dataset in. Click on Automatically Attach Labels to Images based on their folder name, and finally click Create Dataset. This screen will appear showing you the images you have captured. They should all be labeled, and then you can click on Train Model. Information is displayed as to what will happen. The standard defaults are okay, and at the bottom of the page click Train Model. It will now ask you if you really want to train your model. We do, but please remember this will take about half an hour to run, and will also start generating costs in your AWS account. As soon as the model has finished training, a green banner will appear on the console telling you this, and also the status will be changed to training complete. Then go back to the Basler Kit UI window and click OK. Now you can go on to the Inference. In order to do or perform an inference, you first have to start the model. Do this by clicking on Start the Model, which will open the following dialog. Here are various information about the model and where it is stored on the Amazon system. If you have trained more than one version of the model, it can be selected here. The model, as we see, is trained, and so we can now host the model by clicking on the Host Model button. Be aware when the model is hosted, charges start to incur on your AWS account. Do not forget to stop hosting the model after you have finished inference. Hosting the model can take several minutes. Once the model is hosted and running, the display will change so, and you can click on OK to continue, taking you back to the inference page. To perform an inference, first you have to choose a model. Go to Show Model Selection. Then, on the pull-down box, choose the model you want, V1 version 1, and select it. This will be confirmed in the text above the button. Now you can start triggering. So, as always, on the left-hand side is the live image that the camera is currently taking. To take a snapshot of the live image and send it to the inference for categorization, click on Trigger. After a short while, a result will be returned. The image that was sent to AWS is shown as a thumbnail in the bottom right here, and the result from the inference system is shown under Inference Results, in this case anomalous, with a confidence factor. This may be repeated as often as required. After you have finished any inference tests you wish to make, do not forget to stop the model. Otherwise, you will continue incurring costs without actually performing inference. To do this, click on the button labeled Start the Model again, scroll down, and click on the button labeled Stop Hosting. Again, this may take a few minutes. When the model has stopped being hosted, the status will return to trained and the model is ready for hosting. You are no longer incurring any charges. You can click OK.
As you can see, the Amazon Lookout for Vision Accelerator PoC kit really is the fast track to your proof of concept. And this Getting Started guide steers you through every step. Keep in mind that it is a standardized prototyping kit and is suitable for testing purposes only. If you need customized adjustments or have any questions, please do not hesitate to reach out to us via AWS Basler at baslerweb.com. We'd be happy to develop your custom vision solution. Thank you for watching.